In early April 2025, the southeastern United States was hit by a devastating stretch of severe weather and excessive rainfall. It began with a record number of tornado warnings on April 2nd, then from the 3rd to the 6th, relentless rounds of rain followed. Some parts of the central Mississippi Valley saw more than 16 inches, 400 millimeters, of rainfall in just 4 days. Widespread flooding occurred across Arkansas, Missouri, Kentucky, Tennessee, and surrounding states, where rounds of storms dropped torrential rain on an already saturated ground left behind after a wet late winter. In total, 25 lives were lost to tornadoes or flooding, and damages were estimated up to at least $90 million. Now, meteorologically, a stalled front, a boundary between two air masses, remained parked over the region. Strong high pressure to the east funneled in warm, moist air from an above-average Gulf of Mexico, while a sluggish low to the west kinked the jet stream, allowing the atmosphere to be saturated with Pacific moisture. As multiple disturbances moved through, they triggered several mesoscale convective systems, organized clusters of storms, that brought repeated rounds of dangerous severe weather and generational rainfall totals and flooding.
To investigate the influence of climate change in the floods, our study focused on a region that experienced severe rainfall. We first looked at weather observations and found the rainfall is the region's heaviest 4-day spell on record. We also found a clear increasing trend. Since 1950, similar events have become 13 to 26% heavier and 2 to 5 times more likely. Second, we used climate models to understand if and how much of the increase is due to climate change. So the models simulate the event in today's climate with 1.3 degrees of warming and a cooler climate that hasn't been warmed by fossil fuel emissions. Combining the climate models and the weather observations, we found that climate change made the rainfall about 9% heavier and 1.4 times more likely. However, due to some uncertainty in the climate models, we think these results are likely underestimating the role of climate change, which could be much higher. Overall, our results are not particularly surprising. We know that a warmer atmosphere can hold more moisture, leading to heavier rainfall and more dangerous floods. The results also agree with a large body of scientific evidence showing that extreme rainfall is increasing in this part of the US.
Our study also looked at how heavy rain will change in the future. When warming reaches 2.6 degrees, which is expected by around 2100 under current policies, similar downpours are expected to become a further 7% more intense and twice as likely. This flood is yet another example of climate change hurting the US. Previous studies by World Weather Attribution also found that climate change made the LA wildfires and Hurricanes Helene and Milton more intense. Of course, we know exactly how to stop things from getting worse. The burning of oil, gas and coal creates greenhouse gas emissions that warm the planet. Using energy more efficiently and replacing these fossil fuels with renewable energy will slow warming. When we reach zero emissions, the intensification of extreme weather events around the world will stop. We also know that preparing for extreme weather is critical to save lives. The US National Weather Service forecast the floods a week in advance and issued warnings throughout the event. As a result, people in the region knew exactly when they needed to evacuate and the death toll was minimized. However, nearly half of National Weather Service field offices have vacancy rates of 20% or more, double the level of short staffing from 10 years ago. Recent job cuts in the forecasting and disaster workforce are extremely concerning and will threaten public safety and will put more lives at risk.